You reach across the fire for something and your hand goes too close. Or you're cooking and fat spits onto your forearm. Or you fall asleep near the embers and wake to the smell of your own skin. The pain is immediate and absolute. There is nothing quite like it, nothing that demands the body's full attention as completely as a burn. You've had this happen. Maybe a small burn from a pan, maybe a splash of boiling water, maybe a moment of distraction near something hot. And your first instinct, that very first instinct before thought, is to pull away, and then to put the burn under cold water, or to reach for something to put on it, or simply to hold it and try to make the pain stop. That instinct is ancient, older than recorded history, older than fire itself, in its most basic form. Because fire was not invented by humans, it was encountered long before we learned to make it. And something that encounters fire will occasionally be burned by it. What did early humans do when they burned themselves? Not in the broad sense, but specifically, practically, with the tools and knowledge available to them. And what does the answer tell us about the surprisingly sophisticated understanding of wound care that existed long before anyone wrote a medical textbook? Let's get into it. First, let's understand what a burn actually is, because the biology determines the response. And the biology of burns is both more complex and more instructive than most people realize. A burn is not simply a wound the way a cut or a puncture is a wound. A cut disrupts tissue. A burn destroys it, at multiple levels, depending on severity. The classification we use today, from first-degree to third-degree burns, reflects the depth of tissue destruction. A first-degree burn, redness, pain, intact skin surface, has damaged only the outermost layer of the epidermis. A second-degree burn has damaged through the epidermis and into the dermis below, producing blisters, significant pain, and the beginning of a complex wound healing process. A third-degree burn has destroyed the full thickness of the skin and damaged the tissue below, nerves, blood vessels, fat, sometimes muscle and bone, and paradoxically produces less pain because the nerves themselves have been destroyed. The primary biological challenges of a serious burn are infection, fluid loss, and temperature dysregulation. Skin is not simply a covering. It is the body's primary barrier against the outside world, against pathogens, against fluid evaporation, against temperature extremes. When a significant area of skin is destroyed, all three of those protective functions are compromised simultaneously. The wound is immediately vulnerable to infection. Fluid pours out of the damaged tissue. The body loses its ability to regulate temperature in the burned area. These were the real threats that ancient humans faced when they suffered significant burns. Not just the pain, which was severe, but the secondary consequences, the infection, the fluid loss, the risk of what we would now call sepsis, that could kill a person days or weeks after the original injury. The good news, and it is genuine good news, is that humans have been dealing with burns for as long as we have been using fire. And the use of fire by early humans appears to go back at least 1 million years, based on evidence from sites like Wonderwork Cave in South Africa. That is 1 million years of humans burning themselves, and 1 million years of accumulated empirical knowledge about what helps. Researcher Andrew Sorensen at Leiden University has analyzed burned bone and plant material from ancient hearth sites and found evidence of fire management sophistication that implies close, prolonged human interaction with fire, and therefore ample opportunity for accidental burns and ample motivation to develop responses to them. The most important immediate response to a burn, one that appears in traditional medicine traditions on every inhabited continent, is cooling. Applying cool water, cool mud, cool plant materials, cool anything to a fresh burn reduces the temperature of the tissue, limits the depth of tissue destruction, reduces pain, and begins the process of wound stabilization. This is not superstition. This is biology. A burn continues to damage tissue for minutes after the initial contact with the heat source, because the heat has penetrated the skin and continues to denature proteins and destroy cells even after the heat source is removed. Cooling the burn rapidly, within the first few minutes, limits this ongoing damage. Modern burn treatment guidelines still recommend 20 minutes of cool running water as the first-line treatment for burns. The principle was discovered empirically, probably very early in human history, and has been consistently applied across traditional cultures ever since. The second major category of burn treatment in traditional medicine is wound covering, protecting the raw, damaged tissue from the environment. This serves multiple functions, reducing infection risk by physically blocking pathogen access to the wound, reducing fluid loss by providing a barrier layer, reducing pain by protecting exposed nerve endings from air exposure and mechanical trauma. The materials used for wound covering in traditional burn treatment are remarkable for their diversity and their functional sophistication. Honey appears in burn treatment traditions on multiple continents, and honey is not arbitrary. It is genuinely antimicrobial. Its low water content creates an environment hostile to bacterial growth. Its high sugar concentration draws fluid out of bacteria through osmosis, and it contains hydrogen peroxide and other antibacterial compounds produced by the bees themselves. Modern clinical research has confirmed that honey, particularly Manuka honey, has significant antibacterial activity against burn wound pathogens, including Staphylococcus aureus and Pseudomonas aeruginosa, precisely the organisms that cause the most serious burn infections. Aloe vera appears in traditional burn treatment across Africa, Asia, and the Americas. Its gel contains compounds with documented anti-inflammatory and wound-healing properties. Research published in the journal Burns has confirmed that aloe vera accelerates healing of superficial burns compared to placebo and reduces pain through mechanisms including the inhibition of thromboxane A2, a compound that causes tissue death in the margins of burn wounds. Clay and mud, which appear in traditional burn treatments across many cultures, have their own functional logic. Applied to a fresh burn, cool wet clay serves the cooling function described above. As it dries, it forms a protective covering layer that reduces fluid loss and limits environmental exposure to the wound. Animal fats and plant oils, applied after the initial cooling phase, form an occlusive layer over the wound that reduces fluid evaporation and protects the wound surface from mechanical trauma. This is the functional principle behind modern petrolatum-based wound dressings. The fat is different. The principle is identical. What about burns that were serious enough to destroy skin and create open wounds? Because these were the burns that actually killed people, not the small splashes and contact burns that could be managed with cooling and covering, but the serious injuries that exposed the deeper tissues and created wounds that needed to heal over days and weeks. The management of serious burn wounds in early human communities almost certainly involved the same social structures we have seen in other contexts of serious injury and illness. The group adapted. Other members took on the burned person's labor responsibilities during recovery. Food was prepared in ways that could be consumed by someone unable to use their hands or arms. The wound was tended by whoever had the most experience or skill, whether that was a designated healer in more complex societies or simply the person who had seen burns heal well and who knew what to do. The specific plant interventions for managing serious burn wounds are documented across traditional medicine traditions with striking consistency. Plants with significant antimicrobial activity, garlic, turmeric, certain tree barks, appear in wound poultices across cultures. Plants with anti-inflammatory properties appear in dressings and washes. Plants with specific wound healing effects, plantain leaves, which contain compounds that promote epithelialization, the regrowth of skin over wounds, are documented in traditional burn treatment on multiple continents. Researcher Monika Schmelzer at the University of Vienna has analyzed the antimicrobial properties of plants documented in ethnobotanical records and found that traditional burn treatment plants showed antimicrobial activity against clinically relevant pathogens at rates significantly higher than chance, evidence that the traditional pharmacopoeia of burn treatment was not random but reflected genuine empirical discovery of which plants actually worked. There is something remarkable about the fact that humans began learning to treat burns at roughly the same time, and perhaps in the same place, as they learned to use fire intentionally. Fire and burn treatment may have co-evolved. The development of fire management would have created immediate selective pressure for the development of burn treatment knowledge. Communities with better burn treatment would have had more of their fire-experienced members survive to teach the next generation of fire users. This is a pattern that appears across the co-evolution of human technology and human medicine. Every new capability creates new injuries. Every new injury creates selective pressure for new treatments. The people and communities that developed effective responses to those injuries survived to continue developing the technology. The burn is one of the oldest occupational injuries in human history, and the treatment of burns is one of the oldest branches of what would eventually become medicine. There is also the psychological dimension of burns that deserves attention. Burns are among the most painful injuries a human body can experience. The pain is not only immediate, it persists through the healing process, with the exposure of nerve endings and the inflammation of healing tissue creating ongoing suffering that can last weeks. In the modern world, this pain is managed with pharmaceutical analgesics and careful wound care. In the ancient world, it was managed with what was available, and what was available included something we should not underestimate: the presence of other people, the care of a group, the comfort of being attended to, of having the wound tended, of not being alone with the pain. Researcher Fabian Grabenhorst at Oxford University has studied the neuroscience of pain and social context and found that social support, specifically the presence of a trusted other, measurably reduces the subjective experience of pain and reduces the physiological stress response to it. The ancient burn victim who was tended by a parent, a partner, a group member with experience, was receiving a genuine analgesic effect from that social care. Not because anyone understood the neuroscience, because human bodies are calibrated to experience less pain when they are not alone. One last thing before we close. The earliest written medical texts, the Edwin Smith Papyrus from ancient Egypt, dating to approximately 1600 BCE and believed to be a copy of a much older document, contains systematic descriptions of wound care, including burn treatment. The treatments described include honey, animal fat, and plant materials applied to wounds. They describe assessment of wound depth and severity. They distinguish between wounds that can be treated and wounds that cannot. The ancient Egyptian surgical tradition had a concept of prognosis that is recognizable to modern clinicians. This is not primitive guesswork. This is the codification of accumulated empirical knowledge that had been building for thousands, probably tens of thousands, of years before anyone wrote it down. The Edwin Smith Papyrus did not invent burn treatment. It recorded what was already known. And what was already known: the cooling, the covering, the antimicrobial plants, the social care, the observation of what worked and what didn't across generation after generation of burned people, represents one of the longest and most consistently successful empirical research programs in human history. The next time you reach for the cold water after burning yourself, you are performing an act that is at least 1 million years old. You are doing what humans have always done when fire does what fire does. If this one made you look at your kitchen burns a little differently, you know what to do. I'll see you in the next one. There's one more layer to this story that I want to spend time on: the question of scarring and what scars meant in early human communities. A significant burn leaves a scar. Not always. Minor burns may heal without visible scarring. But burns that penetrate deeply enough to damage the dermis will almost always leave permanent marks. The texture of burned skin, the tightening of scar tissue, the change in pigmentation, these are visible, permanent records of what happened. In modern culture, burn scars are understood primarily as cosmetic concerns and functional impairments. Scar tissue contracts as it forms, and if a significant burn affects a joint, the elbow, the knee, the fingers, the contracture can limit movement significantly. This was a real and serious complication for ancient burn victims. A contracted scar across a major joint could reduce a person's functional capacity permanently, affecting their ability to hunt, to gather, to process food, to participate in the full range of group activities. But scars also have social meaning, and the social meaning of scars in traditional cultures is considerably more complex than simple stigma. In many traditional cultures, scars, including burn scars, are read as evidence of survival, as proof of having encountered something dangerous and come through it, as marks that carry stories. Researcher Lars Krutak, who has spent decades documenting traditional tattooing and body modification practices worldwide, has noted that in many traditional cultures, the deliberate creation of scars through burning, scarification, is practiced as a rite of passage, as a mark of identity, as a form of beauty. The same tissue response that produces an accidental scar after a fire injury is intentionally induced to create permanent body marking with cultural meaning. This is not incidental. It reflects the deep integration of burning and scarring into the cultural understanding of the body in many traditional contexts. The accidental burn scar and the intentional scar coexist in the same cultural universe, and the meaning of each is shaped by the existence of the other. An ancient person with a significant burn scar was carrying a visible record of an encounter with fire. And fire, in most traditional cultures, is not merely a tool or a hazard. It is something closer to a force, dangerous, necessary, transformative. The person who had been burned by fire and had survived was someone who had encountered that force directly and had not been destroyed by it. There is also the practical matter of what ancient communities did to prevent burns from happening in the first place. Because the archaeological record gives us evidence not just of burn treatment, but of burn prevention, the development of tools and techniques for managing fire more safely. The earliest hearths, fire management structures documented in the archaeological record, show evidence of deliberate containment. Stones arranged to control the spread of fire, ash pits that suggest the careful management of embers, cooking implements that put distance between the hand and the heat source. Researcher Dennis Sandgaith at Simon Fraser University, who studies Neanderthal and early modern human fire use, has documented the gradual sophistication of fire management practices and argued that this sophistication was not simply about efficiency or cooking quality, it was also about safety. The development of longer cooking implements, of containment structures, of techniques for managing fire without direct hand contact. These represent accumulated learning from the consequences of insufficient distance from the heat source. Every burned hand that taught a lesson was teaching not just the individual, but the group. The observation of what caused burns and what techniques reduced them accumulated into a cultural knowledge of fire safety that was transmitted across generations. The development of the long cooking stick is, among other things, a burn prevention technology developed by people who had learned, empirically, that shorter sticks meant burned hands. The same logic applies across the development of heat-resistant containers, of techniques for moving coals and embers, of the understanding of which materials were more or less likely to conduct heat to the hand. All of this knowledge was accumulated through experience, including the painful experience of burns, and transmitted as cultural learning. The treatment of burns and the prevention of burns are two sides of the same empirical coin, and both represent something that deserves genuine respect: the systematic application of human intelligence to one of the most fundamental hazards of the technology that defines our species. Fire made us human, in important ways. It transformed our diet. It extended our active hours into the night. It changed the social dynamics of our groups. It protected us from predators. It gave us warmth in environments we could not otherwise have survived. And it burned us. Regularly, inevitably, painfully. The response to those burns, the cooling, the covering, the plant medicines, the social care, the accumulated empirical knowledge of what helped and what didn't, is part of the same story as fire itself. It is what it looks like when a species takes on a powerful and dangerous technology and figures out, generation by generation, how to live with it. Let me close with something about the relationship between fire and what it means to be human. Because the burn is not just an injury, it is the price of the relationship. Humans are the only species that cooks food. We are the only species that uses fire as a regular controlled tool. And the relationship between early humans and fire was not simply instrumental, not simply a matter of using a resource. It was something closer to a co-evolutionary relationship, in which the use of fire shaped human biology, human social structure, human cognitive development, and human culture over hundreds of thousands of years. Richard Wrangham at Harvard University, whose work on fire and human evolution has been influential and sometimes controversial, has argued that cooking was not simply useful, but was actually a driver of major anatomical changes in the human lineage: the reduction of the gut relative to body size, the change in tooth size, the change in jaw musculature. If Wrangham is right, cooking fire did not just supplement the human diet. It changed the human body to fit a diet that required fire to prepare. If that is true, then the burn is not just an occupational hazard of a useful technology. It is a consequence of a relationship that made us what we are. We cook because our biology requires it. Our biology requires it because our ancestors cooked. The burns that those ancestors suffered were the cost of the relationship that produced the bodies we now inhabit. This is not the first time in this series that we have found an ancient human experience that connects in unexpected ways to the deepest facts about what we are. The burn, painful, immediate, managed with cool water and honey and social care and accumulated empirical knowledge, is one thread in the larger story of what it has cost to be human and what we have built in response to that cost. The next time you pull your hand back from something hot, you are doing something your body has been calibrated to do for 1,000,000 years. And the next time you run cold water over a burn, you are doing something that your most distant fire-using ancestors discovered, not through theory, not through science, but through the same empirical process that produced everything useful that humans have ever known. They tried things. They noticed what worked. They told each other. And the knowledge accumulated quietly across more generations than we can count. If this one gave you a new way to think about the next time you touch something hot, you know what to do. I'll see you in the next one.